Good afternoon. It's the first day that feels like spring, and I'm so excited. Today is opening day for baseball. Now that Michigan and U of M are out of the NCAA, I have to start rooting for my Tigers, hoping that we will go to the World Series again this year. Go Tigers. So I want to review just a couple of things about exponential functions. We have a test on this on Friday. And just real quick, we know that if we have like f of x equals, let's say, 1 times 3 to the x power. This is in our standard formula, which is f of x equals a times b to the x. Now, we found out through our class explorations that the a indicates the y-intercept, the b indicates the steepness of the curve. It spells curve in cursive, sort of. Okay, so if we're looking at this function right here, I know that it's going to cross the y at the a. I know my b is 3, which is going to indicate the steepness. If I want to graph it, I know I'm going to have a point here, and then I can pick points. If I put 1 in for x, just to make a table, if I put 1 in for x, which will be 1 times 3 to the 1, this would be 3, and my y will be 3. So I know I have a point at 1 and 3. I could do the same thing with 2. If I want to know when x is 2, what will y be? 3 squared is 9 plus 1 is 10. So I know at the 1, 2, 3, y is going to be 10. And this gives me a good idea of the curve. And you can see that it's hard to draw with this pen. That was supposed to be a curve. Let's try that a little bit better. Bad. Sorry. I hope you get the idea though. Curve. So we have our y-intercept here. Now there's a couple of things we need to keep reminding ourselves of that you'll be tested on. Okay? So this is the standard formula for slope-intercept. You should know that this is the y-intercept and this is the b is the steepness of the curve. I can also write that as f of x equals 3 to the x power, since 3 to the x times 1 is 3 to the x. So if it's written in this form, you have to know that there's a times 1 for the a, because you can see the a is missing. So you have to assume that a equals 1, and that's your y-intercept. Okay? So this is called your base function here, f of x 3 to the x power. Okay? We have to know how to do several things. 1 is the y-intercept, what we just did, and that is at 0, 1. The x-intercept, which is the x-axis, we know that this is called the asymptote, right? It's that funny word. Okay? And that means it hugs this line but never covers it, okay? And you have to know that the equation of the y-axis is y equals 0. So the asymptote of this equation is y equals 0. This equation will follow along the y or x-axis and never ever cross it. Okay? We're going to look at another example of that in a minute. The other thing we need to be firm on is domain, and that is your x coordinates. And you can see that this graph goes forever to the right and forever to the left. It's going forever this way and this way. So our domain should be all real numbers. And you're going to have that'll be on your test. Your range, you need to get in your mind out of statistics, and that's your y coordinates or your y values. So we can see here's my y-axis. None of the graph goes below where y is 0. All the graph is above 0. So my range is going to be y is greater than 0. Okay? So those are a few things that we need to understand. All right, so let's look at one other example here. Here I notice this is my base function. Okay, so this is called the base function or the base equation. And you can notice here, remember that's y equals 2 to the x power. It's exponential. Oops, didn't mean to do that. Which our equation is a times b to the x. Notice there's just this part here, 2 to the x power, which is your b to the x, no a. So we assume that a is 1. So that is our y-intercept here, right? If I didn't have a calculator and I want to do this, I can just make myself a little table, x and y. So if I want to know when x is 1, I replace x with the 1. That'd be 2, and so it's 2. So my point here is 2, 2, right? When x is, oh no, that should be 1, 2, sorry. When x is 1, y is 2, right? Because my x here is 1. When my x is 2, my y is 4. 2 squared is 4. So that's 1, 2, 3, 4. Okay? And you can keep going. When my x is 3, my y is going to be 8, because 2 times 2 times 2 is 8. So this is very wide, right? So you can see, let's see if I can do a better job on the curve this time. It's going to come through these points, and again hug that x-axis. So again, the asymptote on this one is going to be, hello, the x-axis, which is y equals 0. Okay? So then we're going to look at if we translate that. Now we learned earlier today what happens when we translate things. So let's look at this equation. But this time I'm going to do, didn't want that, sorry. This time we're going to translate. So we're going to do plus 4. Did not want that. Stop that. Plus, oh! So irritating. Is it still there? No. Okay. Plus 4. So again, I have my base equation that I started with, 2 to the x power. But now I'm going to add the plus 4 to it. So we learned in class that this translates up and down. Okay, so if my y-intercept is at 1, this whole thing will translate up 4. So 1, 2, 3, 4. So now it's going to come up here. Okay, so this whole graph shifts. I don't know if I can, let's give this a try. There we go. It's a bad graph, but we'll try it. The whole thing just shifts up 4. Okay, so this one right here was my y equals 2 to the x power. This one is y equals 2 to the x plus 4. It shifted up 4 units. That's what the plus 4 does. And now you can see the asymptote is also different. The asymptote is running along this horizontal line now, which is 1, 2, 3 on the y. So now my asymptote would be y equals 3, okay? Because again, it's going to hug this line forever and never cross it. So this is a case where the asymptote is different, okay, not just the y equals. The domain would be the same, which is all real numbers. This one, the range is y equals 0, but this one is never going to cross the y equals 3, so my domain for this one would be y is greater than 3, because this graph right here is above the 3 on the y and higher, okay? And so we'll get on with it. My phone's ringing. All right, so that's pretty much it for tonight. Come in with some notes, and we're going to practice this tomorrow. Have a good one.